Okay, good afternoon to everyone, and good morning to participants that are coming in from the Western time zone. My name is Jim Dooley. I'm the business. I work in the business development group for Viking. I'm based out of Philadelphia, and in all likelihood, I've probably talked or got involved in Teams meetings with some of you in the past. So today we're going to be demonstrating vCalc. vCalc is integrated into Revit with a desktop component, and today Brendan Kerrigan will demonstrate in the Revit model for everyone. So I'm going to pass it on to Brendan now, and Brendan, it's all yours.
Great. I guess we're starting a couple minutes early here, but it's all right. So up on my screen here, I've got the main Viking website. So here, I like to point out a couple things as we get started. So here under the training dropdown, there is a link to our customer learning portal. So as you guys apply for access and get access and receive the email that says, hey, you do have access to the vCalc program, it will also have these links as well. But under this customer learning portal here, we do have some content specifically about the vCalc program and how to do a few different things within it, such as adding your own pipe types and internal diameters, equivalent lengths, etc. So it's kind of a little self-guided learning setup there for you, so that can be pretty helpful as well. If you've only heard about vCalc and haven't requested access yet or received access, if I go to the digital drop down here, this is where you can get access to a number of our web-based utilities, such as our sprinkler selector, valve and system configurator, as well as some of our special hazards estimators. And right in the middle here, the Viking Tools for Revit link will take you over to our digital site. So this is where you can download the program. So under the vDesign tab up top, and again, there'll be a link when you do receive access, there's a sign up and download option. And this will download a single installer, and this has our vDesign tab in the Revit ribbon, which I'll briefly touch on. It has our vCalc tab in the Revit ribbon, and it does also include the standalone desktop versions of the program, so that'll install it in all the years of Revit that you've got installed, as well as the desktop version. If you don't quite have access yet, if you were to go to the vCalc tab up top, you can click the Request Access Now button, and you just fill in this little form here, and then you'll end up hearing back from us once you've received access, or if we just need to ask you any additional questions. As it says at the bottom, really the program's only available in the Americas, so North, South, and Central America is the intended audience at this point, with some kind of broader overseas markets eventually going to be coming. Back on the digital page, if you were to go to the resources drop down up the top right, we do also have a link to some frequently asked questions, as well as some tutorial videos. So as I mentioned, I'll very briefly touch on what the vDesign tab is in Revit, but here we do have some tutorial videos on kind of each of the utilities that you'll see in there. So that can be pretty helpful if you're a little curious about a few more of those things as well. So with that said, I'll move us over into the Revit environment. So here I've got Revit 2022 open. So officially we're supporting Revit years 2019 through 2024. And as additional versions of Revit come out, we do an update, and usually we trigger an email to all of our registered users, just giving you a heads up that, hey, there's a new version of the program out, and in those release notes, it'll tell you once we support, for instance, Revit 2025, which is kind of coming around the corner here pretty quickly. Once you do install the program, you should see a couple of extra tabs up top in your ribbon if you do install it, and you only see the vDesign tab. That just means you haven't been granted access to the vCalc program yet. So you could go fill out that access form, or reach out to your Viking, business development or sales rep, and then we can get that sorted as well. On the vDesign tab, this has been available for a while as the Viking tab, but we've kind of gone through a rebranding of sorts recently. So you may see it referred to as the Viking tab on the ribbon. And you may see the vCalc program referred to as the hydraulic assistant, so it's just the same program. We recently renamed them. On the vDesign tab in Revit, this is where you can get access to families for pretty much all the manufactured Viking items. So kind of on the left-hand side here, we've got some kind of broad categories. So if I were to go into the valves option here, this is going to load up with all the different valves that Viking offers. And we have it kind of in a categorization similar to what you might see on our website. So that's one method of accessing our Revit families. And then in the middle here, we have access to some of our web-based utilities like our sprinkler selector and valve and system configurator. This is another way of getting access to some of our Revit families. So it can be pretty helpful if you're not exactly sure what you're looking for. Helps you filter down and configure things pretty well. And then under the utilities section here, this is where we just have some kind of helper functionalities to help you automate some connection strategies in the Revit environment and do some other kind of cool stuff. So the idea is that, you've already got your Revit model laid out when it comes time to run your hydraulic calculations. So obviously you can do that just through vanilla Revit. You could use some of our utilities and our families. But basically all we're really expecting is that you've got a well-connected Revit model. And as you see, as we go through the process of running calcs on it here, we're pretty agnostic about how you actually model the system and kind of what Revit families you use. So if your company is already kind of standardized on your own pipe types, your own fitting families or sprinkler families, etc., that's all perfectly fine. And you can continue using those while using the vCalc program. So once I navigate over to the vCalc tab up my ribbon, you'll see it looks pretty bare at first. We've only got a home button and an information button. So what rides along with this panel here is a docked panel. So if I hit the home button, you'll see that this little vCalc docked panel will show up somewhere, and you can just dock that like any other Revit docked panel. So as we're going through kind of the various steps of the calculation, you'll notice this docked panel here will change kind of depending on the context that we're in for the calculation at that time. So to get into a project, you just click the new project button, which is up on the top left here. And then once you're into a project, you'll notice the information in the docked panel down here changes a little bit, and we get a lot more options up along our ribbon specific to running the calcs on the current model. So within this dock panel, the very first things that you'll see here is basically your project level configuration options. So up at the top, you can obviously fill in a little bit of contextual information about what it is you're calculating. And then down below that, you have some higher level calculation configuration options. So this is where you could choose if you're doing a demand or a supply side calc, if you wanted to use Hazen or Darcy for your friction loss. And then we do have some other toggles in here just to kind of tweak how the calculations will behave, depending on kind of what you wanted to do or what you want to exclude or not exclude. And in those customer learning portal courses, we do have some pretty good explanatory material about what all these different options do and mean and why you might use them. As far as running the calculations on the Revit model, like I mentioned previously, really we're just expecting a pretty well-connected Revit model here, and we've boiled it down to essentially 3 different steps for running a calc on your model. So the very first step is typically to define where you'd like your water supply to be in the model. So as I kind of zoom in on this water droplet looking pipe cap here, that's our official VHA supply family. So that's one method of defining where you'd like your water supply to be. To actually define it, you can go up to the ribbon and hit the Set Supply button, at which point you're going to get a little dialog here giving you 2 different options, which are these buttons at the bottom. So if I were to hit the Insert Supply button, that's going to load our little supply family there up for us to go drop on the end of a pipe somewhere. If we already have our supply placed in the model, or if we'd actually like to use another more generic element as our supply point, we can use the Select Supply button, which is the route I'm going to go. So once I hit the Select Supply button, this is just going to put me into a mode in Revit where I can come out and grab the element that I'd like to pick as my water supply. So as I'm kind of hovering around over some of these generic elbows, over this fire pump here, you might notice that they're all selectable. So we're not requiring you to use this supply family here or to break into your pipe network if you don't want to. So you can actually pick any pipe fitting any pipe accessory, mechanical equipment, etc. And you could use that as your water supply for the calculation. So that can obviously be pretty helpful if you wanted to maybe go spot check a spot on the riser over here, or just anywhere that's kind of convoluted and you don't want to have to go insert a pipe cap. Once you've settled on the item you'd like to use for the water supply, you just click on it, and then you're going to get another little dialog here, and you'll notice our dock panel is changed again over on the left. So since I've seen this water supply before, it's already got a bit of information pre-filled in for me. So up at the top, we have a contextual name for the water supply. So you can leave this blank if you don't really care about saying it's the city or something else. Next, we have the node. So this is how that supply is going to show up in our noded hydraulic sections. And then down below that, we have some typical water supply information. So we can provide an outside hose allowance. We can provide the static pressure, residual pressure, and flow for the water supply characteristics. And as I mentioned, since I've seen this supply before, it does pre-fill that information based off of the last time I used it. But obviously, you can just click into any of these cells here and set the values to whatever you need them to be for your calculation purposes. Once you have your water supply defined, typically the next step might be to go define your remote area in the model, or at least your initial remote area. So if I move us over into a floor plan view and kind of zoom in over here, you can see I've got a little vanilla Revit filled region, kind of sketching in some sprinkler heads that I'd like to flow in this model. So at this point, you can either extract the pipe network or create a build region, or a design area rather, that you want to calculate. Typically, we recommend going the design area route just because it will end up with some nicer lower node numbers on the sprinklers, but it's kind of up to you which path you'd like to go. So to create a design area, you just hit the design area button up on the ribbon, at which point you'll receive another dialog here, just asking you for, first and foremost, a name of the design area. So you are allowed to have multiple design areas in a single calculation file. So here you might call this your office, or really any alphanumeric kind of input here that you'd like to label that remote area. Down at the bottom here, we've got a few different inputs, and this is what's going to define the required flow out of each of those sprinkler heads. So what you can do here, you have a hand up, Jimmy. Is there a question? Assume that's a mistake.
No, not at all, buddy.
Okay. So down at the bottom here, you've got a few different inputs, and this is where you can define the flow requirements for the sprinklers you'd like to flow. So if this was an ESFR type system, you might come in and only fill in the minimum pressure value here, and you could just leave all the other items here at 0. Since I'm going to just use a density area approach, I'll provide both a density and area per sprinkler head, as well as the minimum pressure. And you'll see once we've picked the method of selecting sprinklers in the model to flow, how that will flow through into the minimum flow determination. As far as determining which head you'd like to flow in the model, we offer 2 different options. You can use a filled region-based approach. And what this will do is it'll allow you to pick a filled region. It'll find all the heads enclosed within it on the same level, and that's what'll be your remote area. If that's not quite working for you, or if you have something really specific you'd like to do, you can also always use the select sprinklers option, and that just puts you into a Revit multi-pick mode, which allows you to go pick specific sprinkler heads within the model. So it's really controlled by you at that point, and you can get really finite and detailed about exactly what you'd like to flow. So for this demo, we'll just use the pick filled region approach. So if I click the button here, it just puts me into a mode in Revit where I can go grab a filled region, similar to how we pick the water supply. And when I click on that element there, it'll go pick which sprinkler heads in the model were enclosed within that region that I drew. So you can see in this dialog that's popped up here that it found 13 different sprinkler heads in the model. It's gone ahead and noted them as 1 through 13. We're going to read the K factor out of the sprinkler family that you drew with. And then you have your density, your area, and your minimum pressure that you defined in the dialog earlier. Next to that, in the slightly grayed out text, you can see the minimum flow column. So this is what we're going to be asking for in a demand scenario. And then once we've done our third step, which is extracting the pipe network, you'll see that we'll have some actual flows and pressures in the results columns on the right over here. Now, within this dialog, anything that's in a darker value is actually something that you can edit. So for example, if you just happen to always draw with a generic sprinkler and the K factor is always K56, but you wanted to use something different, you can actually click into the cell, change a value there, and then when you leave, you're going to get a little pop-up and it's just going to ask, hey, did you mean to change all of those values or did you just want to change that one? So when I click the yes button here, it's just going to update all of the K factors that I'm asking to flow. So even though it was K56 in the model, I've asked it to use a K8 head in the calculation, and you can see that it's updated all those values. You can also use that to mix and match. So for example, if this S1 sprinkler head here, if it had a slightly lower area of coverage I wanted to take into account, I could type that value in, and then when I leave the cell, instead of saying yes to update all the rows, I could just click no, and you could see that this one sprinkler head is going to have a smaller area of coverage and then a smaller minimum flow requirement. The other cool thing in this pop-up here is our locate button, which is this kind of GPS map marker icon. So obviously when you clicked on the filled region, we filled in a table here with 13 different nodes. And you're not exactly sure, what is S1, what is S5. Obviously, we've just kind of automatically named them for you. So what this locate button does, when you click it, it will zoom you to that area in the model, and it'll set it as your currently selected item. So this is one of the methods where you can click on that item, and it'll take you right to it in the model. So it kind of helps you figure out what we've done in our dialog here versus what's actually been done in the model. Another feature of the filled region approach is that there is a refresh from filled region button. So if you wanted, you could actually go and drag this filled region around to a different spot. And then when you hit the refresh from filled region, it'll go pick up all the sprinkler heads that are now enclosed by it. So this is one method of doing a quick spot check of a couple different areas. So now we've kind of done our first two steps. We defined our water supply. We defined some sprinkler heads that we want to flow, as well as what we expect their minimum flow to be. Our third and final step to getting our calculations running is to go and extract our pipe network. So just to explain a little bit about how that works, when we hit the trace pipe button up top, it's going to start at our water supply out here before the fire pump, and it's going to work its way out through all of the connected pipes in Revit, and it's going to start building kind of our hydraulic sections. So that's the reason I mentioned earlier, you do need a well-connected Revit piping network for that to work, because it relies on the connectivity in the model to determine what's reachable and not reachable. If you're familiar with Revit, you know that if you were to just hover over a pipe and mash the tab key a bunch of times, that is one method of checking connectivity in a Revit model, and it works pretty well on a simple model like this. However, on some of the more convoluted or kind of larger models, that might be a little bit hit or miss. So we do have a utility you might want to run as kind of a pre-process, which is our reachable pipes utility up here on the ribbon. And when I click on that, it's going to open up a little dialog here with a few different options and buttons. But what this really boils down to is choosing a color for reachable and unreachable pipes and picking, what option you'd like to execute. So if I click the color reachable pipes button here, you can see that it's going to go ahead and it's going to color all of the elements that it considers reachable from our water supply in with a solid blue here. So this is one method of kind of double checking your connectivity or debugging it if you're running into some issues. And then once you're done, you can just click the remove reachable colors, and then it's going to take all that coloring away. Now, obviously everything in here was pretty well connected, but I'm going to go to my modify tab and I'm going to break one of the pipes on the main on the other side. And I know from experience that causes some of the Revit taps or welded outlets to get deleted on some of these branch lines a little farther down here. And that gives me an opportunity to run the color reachable pipes again. And this is, again, a very visual way of seeing that these branch lines down here, they won't be available within the hydraulic calculations. So any sprinkler heads on them that we've asked it to flow or anything, that's going to cause an error for you in the calculation. You can also bundle this with the color unreachable pipes option. And this is just another way of trying to make them pop and stand out a little bit more to try to figure out what might be going on with your system or with specific errors that you're receiving. And again, you can just remove all the coloring from it when you're done with the utility. So since these branch lines aren't actually contributing to my remote area over on the other main, I'm fine with leaving them disconnected. So that's, fine for my current purposes. So to get on with extracting the pipe network, I just go to the vCalc tab, and then here I just hit the trace pipe button. And then what that's going to do is it's going to pop up this Revit to component mappings dialog. So when I mentioned earlier that you could draw your Revit model with kind of any pipe types that you'd like, or any fittings, families, etc., as you can see here, some of my underground piping, this is what some generic default pipe and a mechanical template might look like. So obviously some of the fittings might look a little bit goofy. If I were to kind of tab over to the rest of the system, you can see there's some grooved fittings, or some grooved outlets rather, some threaded fittings that's got the sprinklers on them and so forth. So you're kind of free to draw with what you'd like. And then what we present you with in this dialog here is not quite your hydraulic sections yet. What this is, it's a list of all the unique Revit things or families and pipe types that we found along your piping network. So on the left-hand side here, you can see the first column is the name of the Revit family. So obviously there's kind of generic pipes. There's things like elbows. You can see a pump horizontal split case from Patterson. So that's our pump family right here. And if I were to click on it and bring our dialog back up, or if I don't hit the supply button by accident, but if I click on that, bring our dialog back up, you can see that this row 3 here is just corresponding with that Revit family. Next to that, we have the type name that we saw. We have a rough classification. So it's a pipe, it's some type of fitting, or unknown. So unknown just means it's literally anything other than a pipe and a fitting, because the mechanical equipment and pipe accessories, it's a pretty broad categorization. So we're not quite sure what it is. And then the really important column here is actually this final column labeled as component name. So what we're doing in this dialog is we're telling the calculations how it should treat each of these types of things that are encountered in the Revit model. So for example, the very first row here is a pipe, and in Revit, it was an FP underground pipe, and it was ductile iron class 350. So if I click on this very first pipe out of my water supply here, you can see in Revit, that's just a pipe type called FP underground. So what we're doing in this column over here is informing the calculation that, hey, every time you see that pipe in Revit, you should treat it as a cement line ductile iron pipe. Now, everything was already pre-filled when I came to this dialog here. So as you map things, we do store that. And as you use the same pipe types and fittings and families over and over again, you'll come in here and you'll see they've all been pre-mapped for you because we've seen them before. So they're kind of saving you a little bit of effort there. But if you're in a different fitting standard, perhaps like maybe the flex head example, you could see that there might be some blank cells in here, and that's just a cue for you that if you want those to have an equivalent length or an internal diameter, you're going to want to go ahead and map those items. So to map them, all you do is you click on the cell here. You'll get a list of the available items to map them to. So these all originate in what we call our component database. So these are all kind of the stock pipe types that we distribute with that. And I'll touch on that a little bit more towards the end here. So we give you kind of a starting point of pipe types, fittings, etc., and you can augment that as you need. So all you're doing when you click in here is you're able to tell us how to treat that item in the calculations. So just for demonstration purposes, I'll map these FP underground pipes to a Blue Brute 305 PSI pipe, and you'll see when I get a little bit further in the demo here that every single pipe section that was built off of these FP underground pipes is going to have a Blue Brute pipe schedule assigned to it. That same idea corresponds with things like elbows, with more generic things such as our pump here. So you can just go through the dialog here and map each of those items how you'd like them to be treated. And once you're satisfied, you can click the Build Pipe Table button down at the bottom right. And you can see that our docked panel over on the left-hand side is now updated. So now we have a little results section down at the bottom left here. So this is where we can see some numerical results. And down below that, there's a little status message in blue that just says, hey, your calculation finished successfully. It took this many iterations, this much time. So as you're going through the various steps, you should notice that this blue status message will actually be kind of updating. And if you hit this point and you're not seeing any results, there's going to be some information in that blue status message there just telling you what's going on. So it might say that, hey, a certain pipe doesn't have an internal diameter or something. And that's just telling you that whatever pipe type you assign to a certain pipe in Revit, we don't have data for it. So you can go create your own component or, change what you map it to and so forth. Once we do have our results, if I go back to the vCalc tab and move over to the View Design Areas button and click on that, this will bring our little design area pop-up back up. And you can see that now that we have the calculation running, our rightmost columns over here do have some information in them. So you can see we've got our flows and our pressures for each of those sprinkler heads filled in now. Anywhere that you see a table like this, you can actually click on the column header to sort it. So this is a pretty quick way to find our most remote sprinkler head when they all have the same minimum flow, for example. So here it's telling us our S13 node is probably the most demanding. It's got the lowest pressure. And if I click that locate button, it'll take me over to that in the model. And this is where you can do your own kind of sanity check here. Hey, makes a lot of sense. It's the most remote head on the most remote branch line. So it seems very reasonable that that would be my most demanding sprinkler head. In addition to viewing the sprinkler specific results, if I go up into kind of the middle of the ribbon up here, there is a little results button. And when I open that up, you'll see that we have the same numerical results on the left-hand side, but you do get a little graphical representation over on the right-hand side. So within this system here, we had a little bit going on. We had our city supply, obviously. We had a fire pump that we included and solved through within the calculation. And then we did also have an outside hose demand. So there is a big legend up the top right, just giving you a heads up what everything is, but pretty straightforward. We've got our city demand in the solid green here. We've got our city supply. We've got our system demand in the solid blue. And this does not have the pump solved through in it. So this is as if the pump didn't exist. And that's why you can match it up pretty well against our pump curve in the dashed green, and then our combined curve up above that. And then in this kind of salmon colored line down at the bottom, this is the demand curve with the pump included in it. And this is helpful when we're solving for things like outside hose allowance safety margins on systems that do have pumps included on them. At any time during this process, there's also an Open UI button up on the ribbon. And what this will allow you to do is actually open up the full version of the program. So when I click that button, you'll see I get a big form popped up here. So what this is actually identical to the desktop version of the program. It basically is the desktop version of the program. So what we're doing in the Revit world, you can kind of think of it as extracting data out of Revit and filling in the calculation program on your behalf based on what we've seen. So we will have another webinar at the same time tomorrow, a bit more focused on kind of the manual entry or the desktop only side of this. But here I'll kind of walk through and explain what we're doing and kind of what information goes into this. So the very first tab we see here is the project tab. And you can see that this looks pretty familiar, hopefully. So this is all the same information that we were looking at back in the doc panel when we initially entered our project. So if we ever wanted to change what type of calculation we're running, what friction loss methodology we're using, we can always come back to these configuration options over here. When we did our first step in Revit and we defined our water supply, you can kind of think of that like coming over to our supply tab here. And up at the top, you can see this is where all of our information about our water supply characteristics, our hose allowances, etc. is defined. So that's kind of similar to coming over here and filling all this information up at the top. And you can see down at the bottom, once you do have some results, this is obviously somewhere you can also get a much larger graph than the smaller results pop up. When we did the next step in Revit, which was defining our remote area, that's kind of like coming over to our design area tab and filling in this table here about what nodes in the calculation we would like to flow and what all their characteristics are. And very similar to the pop-up dialog, obviously you can edit any of these items here at any time as well. The heavy lifting occurs for us when we do that trace pipe and we inform it how we'd like to treat each of those pipe sections. So when I move over to our pipe sections tab, This is what gets built when we extract the piping network out of the Revit environment. So you can see here, kind of working left to right, it should look like most calc programs probably. It's pretty straightforward in terms of what a hydraulic section is. So in kind of the leftmost area, we've got our ending and starting nodes. So you can see here that our default prefix for anything that isn't a sprinkler is just going to be an N. But the same idea as the design areas, you can actually click into any of these cells here, and you can change any of these node names as you'd like. So here, if I wanted to call out some of my underground piping, I can just come through and start changing the names. And you can see that all I need to do is change it in one spot, and it'll change it everywhere else that node was used as well. Next to that, we have the assigned pipe schedule. And you can see that for all of this underground pipe, so starting at my source, working its way out, that was all treated as a Blue Brute 305 PSI pipe. So I like to kind of show this side by side here as another reminder of how that mapping works. So if I kind of move my full UI over to the side there, I go back up to my ribbon and I click the View Map button. I can have my component mappings open on the left, open the full UI on the right. So this is just kind of a demonstration just to, again, show how the mapping works. So back in the mappings, we said, hey, every time you come across a pipe and it's an FP underground pipe, I want you to treat it as a Blue Brute pipe in our calculation. If we want to change that, so in Revit it said it was a ductile iron class 350, I can just click in, say, hey, let's actually treat that as a cement line ductile iron pipe. And when I click my Build Pipe Table button here, we'll see that all of those pipe schedules are going to update in my pipe sections. So it's pretty easy to swap between different mappings, but hopefully that's a pretty visual way of understanding when you're filling in that mapping table there, how that flows through into our pipe sections table over here. And obviously when you do that, switch the mapping, that now means that these sections are using the C factor and the internal diameters for the appropriate size pipe for each of those pipe sections as well for the new pipe schedule. Following that, we've got our diameter. So this is going to be based off of what was drawn within the Revit model. We have the pipe length. So this is the center to center pipe length based off of what we observed in the Revit model. And you'll see over here, we do have an EQL tab. So things like fittings, etc., those get accounted for separately from this pipe length column here. The direction column, this column is always going to be blank in the Revit environment. In the desktop, you have kind of a option of using an XYZ direction here, and that ties into our standalone 3D viewer, which I'll show kind of towards the tail end of this. But in the Revit world, we kind of recreate the real direction out of Revit, so this will be blank for you here. We have our starting and ending elevations based on the Revit model. And then this components column here, this is where we're accounting for any fittings. So for instance, you can see some of the elbows as the 1E. We can see our fire pump. We can see our butterfly valve and alarm check valve here. So this is where all of your various fittings like elbows, T's, other items like backflow preventers or valves, etc., will get accounted for. And then finally, on the right-hand side over here, these are all the non-editable kind of results-based items. So the EQL column here, this is the modified equivalent length, if it needed modification. We have the length, so this is the total length that was calculated for each of these sections. We have the direction of flow and the actual flow in each of the pipe sections, friction loss for elevation due to fittings and pipe flow. You can see a negative 107 PSI friction loss here. So we do solve through pumps, assuming you don't have exclude pump toggled on the project tab. And you can see in the right-hand side here under the pump effect column that we're reporting out the pump's impact. So you're allowed to have one pump, multiple pumps, pumps in parallel, and it should solve through those for you. And then you end up at your starting and ending pressures, velocities, etc. Now, if I scroll down a little bit, you can see that this is a pretty lengthy table here. So essentially, every single pipe in Revit becomes a row in this table here. This is to support the idea that you could have multiple design areas, multiple different flowing paths, etc. So obviously, this can be a pretty heavy table here since it's kind of a pipe per pipe. So that is the purpose of our Simple Sections tab, which is the tab next to Pipe Sections up at the top. And if I navigate over to that, you can see this is a much more concise view here. If you're kind of following the components column, you can see that some of it's a bit more amalgamated here. So this is going to be a lot closer to your NFPA 13 pathing. So it's going to condense down all your typical sections for the current design area. And I've added them all up into one. So this is obviously only all your flowing pipes. And this can be a pretty handy way of maybe interpreting the results a little bit easier than trying to go through that full pipe sections tab. And similarly to all the other tables, again, if you click on the column headers, you can sort them. So if you wanted to do, a quick check on velocity, or you wanted to see where you're losing all your friction loss, you can come sort these columns, ascending, descending. That's a pretty nice way of interpreting what's going on within the calculation. So that covers kind of the first group of tabs here. Those are all the things we're kind of typically filling in the Revit environment. We do also have a fixed flow PRV tab. So if you wanted to do something like a standpipe calculation, or if you wanted to add a pressure reducing valve, you can do that here. And we'll cover that in the desktop version tomorrow. It's pretty typical between the Revit and desktop version. We have a nodes tab. So this is a summary of all the nodes in the project, whether they were sprinklers or not, their elevations. And then finally a bulk edit tab, which we'll also touch on a little bit more tomorrow. So in the Revit environment, again, we're kind of filling in this information in these different tabs along the top here for you, and you are allowed to make changes in here. So for example, if you just drew a very short little stub pipe for your underground, you could come in after the fact and say, hey, that was actually a 350-foot long piece of pipe. You could add a bunch of elbows to it, so you don't have to actually draw one-to-one in the Revit model versus the calculations. And if I go look back at my model, you can see it's still the same short little 7-foot section of pipe here at the start. So you are allowed to go kind of make changes within the calculation itself. It is a one-way street. We're pulling out of Revit. We're filling in the information in the dialogues here, calculating based off what you provided. So this isn't going to end up pushing anything back into Revit, but you are allowed to tweak it to try to see what might make your calculations work. Now, if you wanted to go the other way, you didn't want to just update the calc, you wanted to update the calculation based off of something you've done in Revit, all you've got to do is hit the trace pipe button. So you can go make a change in your Revit model, and then you just hit the trace pipe button, and it's going to go update your hydraulic sections based off of whatever impact or whatever change you've made. Once you're kind of satisfied with the calculation, at any time you can kind of create your printout. So that's what this Create Submittal button does. It's the printer icon up on the ribbon, and the same icon is available in the full user interface. So if I click the Create Submittal button, you can see we're going to get another little dialog here with a few different tabs along the top. So down at the bottom of the very first tab, your print options are here, and this is where you can choose what you would like to include on your printout. So the first column here, this kind of corresponds to each of these tabs along the top. So these allow you to fill in some typical kind of cover sheet info that NFPA might require. And if you don't want to include any specific information tabs, you just uncheck the boxes here. The grouping on the right-hand side, these are all just result-based information. And then there are some options for including the basis of the equivalent lengths or curves, etc. as well. So I'll do kind of a full printout here, minus a couple of the cover sheet tabs, and we'll kind of walk through what's included on that. But I will go over to my design area tab or my design tab. So if you did want to fill in some cover sheet information, you can just come in here and type whatever, kind of fill in what you want, leave blank what you don't want. So this could be my office on first floor, for example. I might say this is an ordinary hazard situation. Kind of fill in whatever density area specific information that you use for that specific design area. Again, you can leave blank anything you don't want to fill in. And once you're satisfied, you can just click the print button, at which point in your default web browser, you'll see an HTML file open up, which is your hydraulic calculation summary sheet. So from here, you can just Control P or right click print, and you can just save this out to a PDF. So if I kind of scroll down in the print preview here a little bit, you can see it's reasonably well paginated. So the idea is that you can just print this out to a PDF, and that's kind of your submittal, your final document. I'll walk us through the contents of it on kind of the larger version here. So up at the top, you'll get a little printout with, what version of the software you utilize for this calculation, and this printout. Down below that, this is where you've got some of those kind of cover sheet headers. So I have included the project info and the design info. And you can see here that this is where some of that information that I filled in is going to flow through into my results as well. You'll also get some kind of free information. So we'll print out things like the total system volume. If you had some dry pipes called out in there, you'd get the volume of the dry or pre-action as well, broken out separately. And then we just have some result-based information below that, as well as all the options that went into the calculation. So this kind of has everything you need that if we ever wanted to, recreate this without the underlying calculation file, it should have that as well in here. Down below that, you have your graphical results. So this is going to be that same graph we're looking at in UI and the results pop-up, followed by a little table here with all the numerical result points based off of the calculations. Next, you're going to get your design area analysis. So this is going to be all the important nodes in your calculation. So you're going to have all the elevations, all the K factors for the flowing heads. If you had called out some fixed flows or PRVs in here, you would see those values in the appropriate columns here. And then finally, you have your pressures and flows out of each of those nodes. So again, just your typical node summary, followed by the pipe information section, which is where you'll see your more typical NFPA 13 style pathing. So you can see here that we have a path 0 to start us off, and that's starting at S13, which was our most remote sprinkler head, if you recall. So it's going to just follow the typical NFPA format out through the hydraulically most demanding route, out through our butterfly valve and alarm check valve, out through our fire pump, all the way out to our water supply, which was our SRC node. And you can see some of those renamed underground nodes also flow through into everywhere else that those nodes are referenced. In addition to the most demanding path, you'll just end up with however many other paths it takes to show all the flowing sections. So if this was a gridded system, you might end up with a whole bunch of different paths, depending on which way the water is flowing and which transfer lines, etc. Down below that, we have our simplified pipe table. So this is all the same information in that simple sections tab. It's a really concise way of bringing all the data from the calculation and including it on your submittal. So generally, this is what I'd recommend to include as well. And then I did opt to include what we call kind of the EQL details and the curve details. So I'll touch on the component manager, so where all these things live in a little bit here. But basically, this gives you the ability to print out our EQL tables or any of the curves that were used and include them on the printout. So you can see in this table here, the equivalent length for each nominal diameter for a T, for an elbow. And this will let you go cross-reference with the tables above based off of, just let you kind of figure out what we utilize for the basis there if it wasn't clear. And it's a similar idea with the pumps or anything that's curve-based, like a backflow preventer. We'll include all the X and Y coordinates that built out that curve. So kind of full transparency on the data input there. And then finally, down at the very bottom here, we have our full pipe table. So this is all that information on the pipe sections tab. You can see things like the real internal diameters that were used come through here, C factors, roughness coefficients, etc. So this is kind of a big full data dump of everything that went into the calculation. Probably a little bit much for your typical printout, but the option is there if you did want to include it and just have a whole bunch of information there conveying everything that went into the calculation. Another kind of follow-up that you might do once you're kind of happy, or if you were trying to figure out a little bit about what nodes what in the model, we do have some tagging capabilities up on the top right here. So if I were to lock my 3D view here, go to our tag nodes dropdown, you can see we've got a few different options here. So you can tag all the nodes, you can tag all the sprinklers, you can tag the simplified nodes. So this would be pretty close to the important nodes in your NFPA pathing, all the flowing nodes, all the flowing sprinklers. And these are all going to be view and design area specific. So if I were to go over to my floor plan view here, I might come in and say, hey, let's tag all the sprinklers that we're aware of in this view. And when I run that command, you can see I'm going to get a bunch of tags popped in here, just showing me all the sprinklers we're aware of. Now, if you recall earlier, when I broke this main and I showed you on the reachable pipes command, hey, we're not able to get over into these branch lines, this is just another reminder for you that if there's no connectivity in the Revit model, when we pull that piping network out, these aren't going to be associated with the calc. We can't use those nodes or those sections. Again, this is just a reminder that that's the case here. If I go back to my 3D view, I could go apply a different tagging strategy here. So maybe I just want to tag all the flowing nodes, and you can see we'll get a bunch of tags pop in at all of the flowing junctions here. If I just wanted the simplified nodes, I can pull these tags out with the remove all tags in current view command. I could come in, tag the simplified nodes, and you can see we'll get a lot fewer tags kind of at the various sections that might be important for us, working the way out. And again, you can kind of add and subtract, so I could add all the flowing nodes back in again. So you can kind of customize what tagging you're doing here. Now within the tagging, you can see some of our rename nodes came through here as well. But another cool feature in the tagging is that it's kind of a two-way renaming function. So if I come over here, I can kind of see, hey, this node 13, this looks like maybe a nice little place to call out my base of riser. So what I can actually do is change the name of the node within the tag here, call that base of riser. Maybe I'll change node 17 to TOR for my top of riser. And if we were to go back to the vCalc tab, open my user interface up, go back into my pipe sections, you can now see that there's a BOR node and a TOR node called out within here. And that's right at my transition between the schedule 40 and cement line ductile iron. And then my TOR is a little bit lower down. So we do have that ability to kind of contextually rename the nodes, and that can be pretty helpful. And then another thing I like to point out here is that there is also a locate button on the pipe sections tab. So if I look at my rows here, I can see my fire pump is on row 4. And if I were to hit that locate button, it's going to take me right over to the start of that section. So that's a pretty handy way of matching up what's in my table here with what's in the model. So obviously, for some of your bigger ticket items like your fire pumps or maybe your riser, maybe not super helpful. You probably know where those are in the model. But if we ever spit out an error message for you that says, hey, pipe ID 116, there's some type of issue, you can use that locate button and it'll take you right over to the right area in the model, and it'll really help you figure out or kind of hone in on where you might be having an issue. So that covers kind of the basic overview of how to operate the calculations in the Revit environment. What I'll now touch on is the underlying data. So if I go back to the vCalc tab, right in the middle here, there's a button for our component manager. And when I click that up, we're going to end up with a pop-up here called the component manager. And what this is where all of our hydraulic information lives for the calculations. So when I was assigning pipes, this is where your internal diameters and C factors live. When you assign fittings, this is where the equivalent lengths live. So what we do is we provide you with kind of a starting point here of items. So if I go into the backflow preventers, open up the AIM section and click on the AIMS 2000 SS, you can see that on the right-hand side, we've got kind of 3 different tabs along the top here. So this very first item I clicked in, you can see the component names a little bit grayed out. The owner says it's V. So anything that we distribute as a starting point, the owner here is going to be Viking, and it's not something that you can actually edit or modify. However, you do have the ability to add your own components. So if I click on the My Backflow Preventer, you can see the owner here is you. I could go click in, I could change the name, I can go change any of the hydraulic information. So this is a completely extensible database for you. Once you've added a component, that lives on your machine. So as you go to a new project, for example, you can continue using that. And if you are a little bit more curious on how to maybe standardize that database, you can always reach out to us and we can give you some heads up on where it is or how you might go about distributing it to more than one person. As far as the types of components, we've got a few different types. The Most complicated type is what we call a curve type component. So typically with a backflow preventer, for example, the manufacturer might distribute some data sheets with loss curves on them. And if I go to my second tab up top, the curve data tab, you can see that I've got a list of nominal diameters on the left-hand side here. And if I click on one of those, such as the 4-inch, you can see we're going to have a point section here, which is a list of all the X and Y coordinates that derive the curve that you're kind of previewing over on the right-hand side. So what you can do with these is you can build out your sets of X and Y coordinates, and this is going to build out your loss curve over here on the right-hand side. And if I were to go to the 6-inch, for example, you'll see we end up with a slightly different loss curve, a different set of points. So for these curve type components, these loss curves are all going to be size specific. You can also utilize these curves to take a flat loss. So if you're working on a project that says, hey, I want your backflow preventer to just take a flat 8 or 12 psi loss. If I click over to my 8 psi component, go to the 4-inch size, you can just build yourself a flat curve here, and this is the same as having a flat 8 psi loss in that pipe section. Another type of component you might encounter is your more typical equivalent length type component. So we build in things like the NFPA 13 and FM 3-0 tables. And if I click on the elbow here and go to the second tab, which is the EQL data tab, this is where your equivalent lengths live. So a lot easier to maintain than your curve type components. You're just typing in your length of schedule 40 C120 pipe here on the right-hand side. So as far as extending this database, if you wanted to copy our elbow and make some adjustments, maybe you have some different sizes you want to add in here, you can right-click any component, you can duplicate it, and that's just going to carry over all the same information, and you can make whatever tweaks you need. You can also click just the Add Component button. This lets you kind of start from scratch and go build out your component from the ground up. Another type of component we include is the flex pipes. So we give you an example of some of the ASC Superflex items. Similar to the fittings, these have a length of the flex pipe and the equivalent length of pipe. In addition to that, we have our pipes. So this is where when I clicked into that mapping dialog and I said, hey, let's use some Blue Brute through a 5 psi pipe, this is where all of those options come from. If I were to click on the Blue Brute pipe here, you can see that on the details tab, this is where our C factor and roughness coefficient live. So that's why we have a schedule 40 and a schedule 40 dry. If I were to click on the dry variant, you can see it's going to be a C100 pipe. It's going to have dry pipe toggled on. If I were to click up on the normal schedule 40, this is the C120 version for the wet pipe. And very similar to the equivalent lengths, if I go to my pipe data tab, this is my internal diameters for each of those nominal diameters. And then the final type of component you might encounter is a pump, and we just give you some starting points here. So very similar to the curve type components, you're just building out X and Y coordinates to build your pump curve. So we give you some kind of stock NFPA examples, but we can also build out some more complicated pump curves with as many points as we need based off of a real manufacturer's data. And for all these different types of components, we do have segments in the customer learning portal that covers how to do them and how to add each type. So the final thing I'll show here is that obviously when I went into the OpenUI version, I mentioned, hey, that's actually the full version of the program. So everything you're doing in the Revit environment, that's totally compatible with the desktop version. And we can actually save out this information we're working with here and go open it up in the Standalone. So if I want, I can pull some basic geometry information out of the model, like walls, ceilings, and floors. So I'll just run our extract geometry tool here, pull open the UI, go to my file option, and this is where I could save or save as this item. So I'm going to save as, I'm going to call it my temp.vdb, and I'm going to overwrite it. And then now at this point, if I want, I can leave the Revit environment. I can open up the vCalc program out as a standalone program, which again, we'll have a webinar focusing more on the standalone opportunities tomorrow. But when you open it up on its own, you get a little splash screen here. I can go into my recent temp.vdb file. If I go to my pipe sections, we'll see, hey, this is all the same information we were looking at earlier. And then this is where we can also go into our standalone 3D viewer. And this is our own kind of representation of the piping network. Again, we'll delve into this a little bit more tomorrow. There's a lot of different options about what you're looking at, what you can see. But you can see you end up with a reasonable representation of your piping network. You can turn some specific results on per pipe. So for instance, you can see flows, velocities, diameters, pressures, and so forth. So again, join us tomorrow if you want to delve a little bit more into that, but a lot of the options are pretty self-explanatory. So with that, I think we'll just kind of take the last 8 or so minutes here, see if there's any Q&A and questions. And then we'll let you guys get on with your day. Okay. So we've got a suggestion from Blaine, suggestion for future updates, like multiple sprinkler nodes in View Designer at once to batch change in smaller amounts versus everything or one. Okay. That might be something we can include in the future. Mary Long, can you please go over providing an equivalent length or similar if your pump/supply is further from the facility than you have modeled piping? Okay, I kind of covered that, but I will loop back to that. As I mentioned, in the Revit version, once we've extracted the piping network, you can actually come in and you can increase the pipe length. So I can change the pipe length here to 350 feet. I can click into the components and maybe I've got, 10 elbows or something on that section. And I can just come add them after the fact. They're going to be included in the calculation, but it's not something you're going to visibly see in the model. Now, if you do ever hit the trace pipe button, that's going to set this all back to whatever it actually is in the model. So you just have to go retweak that again. Blaine Miller, what is the best way to update the software? Typically, we send out an email through marketing to all of the registered users, just saying, hey, there's a new version available. That could be getting caught in your spam mail. I'm not sure. We do have a little notification bubble that we'll probably start using in the next update or two. That'll show both on your Revit ribbon. So I think it's up here on the very right. You'll see a little update available button. I think it's in the dock panel as well, perhaps. And you'll see it in the desktop launch mode as well. So yeah, you should be getting an email, but yeah, you can always just go download the version again as well. Let's see, some more ones. Does the calculation print out the velocities in the main and branches from Harold? Yes, it does. That is in the velocities column, so it's not going to be in your NFPA pathing, but if I just quickly print this out again, scroll through all the stuff we're already aware of, you will see a velocity column in both the simple sections and the full pipe table. So it doesn't break it out by mains and branch lines, but that information is available in the printout here for you to review. When you did the break pipe, the branch lines turned red that were separated, but the main after the break remained blue. Is this a glitch in the software? No, that's not a glitch in the software. Back in the Revit model, this pipe here is still connected. What actually happened is there's usually, I've got to unlock my view here real quick. Now there should have been a tap leading to this grooved outlet, but you can maybe see here, there's no longer a tap there. So when I used the break command in Revit and I split that pipe, Revit actually automatically deleted this tap on me. It broke my connectivity through this riser nipple up to the branch lines. So this part of the main is actually still fully connected. It's just that the welded outlet or the tap there got cleaned up by Revit. So you can see even the stock Revit, this is showing you that you can't reach those pipes. If I were to zoom in over here, you can maybe see that there's an outlet shown here. So that's what was happening there. And then I don't think there's any other questions. Oh, just now, can a program calculate the system demand if a hydrant flow test is not available? You can. You can just put in kind of like a very small pressure availability from the supply, and it's just a pure demand calc. Really, the supply doesn't impact it in a demand calc situation. Just going to end up with a negative safety margin. So if I were to go back to our interface here, go to the supply. So when you're on the project tab and you're in demand mode, really the supply is not having any impact on the results of the calculation other than telling you what type of safety margin might be available. So it's telling us here, the system demand is 459.7 with a required pressure of 15.52. I mean, you can lower these values here to something lower, and you'll basically end up with the same results either way, depending on what's going on there with the hose allowance up against the system demand. So no real changes there. And I think we're all caught up. Yeah, I think that's everything, at least that I saw. If there was a question I didn't see and you wanted to let us know, you can just go to that digital site, which is under Digital Viking Tools for Revit. And there's a Contact Us link at the top right that goes to our shared inbox. We can reach you from there. And you can also get there in Revit under the vCalc tab, Information, Contact, Tech Services, or Digital Solutions. So if you have a technical question about a product, you can contact Tech Services. If you've got a question about the program, you can contact Digital Solutions. So can we use only fire pump without city water? If you want to do that, you can basically put in a negligible water supply, kind of like what I just showed. You can basically set your city curve to like a 0.2 to 0.1. And this is pretty similar to calculating with only a fire pump. It's, a negligible contribution from the city. And yeah, I think that's all the questions then. Okay, well, I hand it back to you, Jimmy. I know there's some webinar topics that we have available that people may be interested in following up on.
Okay, thanks, Brendan. As always, a great demonstration. And I'd like to thank everyone for attending today's session and hope we see some of you tomorrow. There are other webinars that we can provide on an individual company basis if you're interested. 3 of the more popular topics out there today are the revisions, FM Global revisions to FMDS 8.9. We also have another webinar that covers transition considerations when upgrading from an HFFF to a synthetic fluorine-free foam system. And we also just added a new webinar that covers lithium-ion protection. So if you're interested in any one of those webinars, please reach out to me. We can provide new webinars or at any time during the day that's convenient for you. We offer PDF certificates for all the webinars as well. So again, thank you very much, and I hope everyone enjoys the rest of the day. Take care now.